Okay, 7th graders, it is time to review. Part of this review we have already done together. So the beginning, I will probably go a little bit more quickly, but hopefully you are taking the time to do this so you are prepared and you can be successful on the exam that you do for class. So you'll notice your review packet has Form A in the upper right-hand corner. The assessment you get will be Form B. So it'll be the exact same questions, but just with different people and different numbers. But it's the same exact skill that you'll have to do. So if there's something that you don't know how to do on this review, that means you also won't know how to do it on the test. If you're comfortable with everything you're being asked to do on this review, then you should be good to go with the test. So let's zoom in here. And I know, like I said, some of these we already did together. Keisha's practicing her free throws. She made 5/8 of the shots that she took. Use long division to find the decimal equivalent. So remember, the trick is top in the box. So the top number is 5, so we're putting that in our division box, and 8 goes on the outside, and then I always add 3 zeros after my decimal, just to be sure I have enough. If you forget where the decimal point should go, remember, think about what does $5 look like, and that'd be 5.00. So you can remember that the decimal point comes to the right of a whole number or an integer. So if we are dividing, you just do your long division like normal. That 8 does not go into 5. It goes into 50 6 times, which gives us 48. Subtract and get 2. Bring down the 0. It goes in there twice, which is 16. Subtract and get 4. Bring down the 0, and then that is 5, which is 40, and then zeros out. So we have a 0 as a remainder, and remember that means we have a terminating decimal, so that you know what kind of decimal that is. Terminating. So when we clean up our answer then, 0.625 would be the decimal equivalent of 5/8. For part B, Keisha knows that 1/4 is 0.25. Explain how she could use this fact to determine the decimal equivalent of 1/8. Anytime you're working with fractions and you see that they have different denominators, right away you need to ask yourself, is this a situation in which I might need to get a common denominator? And we know that 1/4 is 2/8. And if we are comparing, we're trying to move from a decimal equivalent of 1/4 or 2/8 to a decimal equivalent of 5/8, then yes, we definitely would want a common denominator so that we're talking about the same size piece. If we know that 2/8 is 0.25, then we would know that 1/8 is half of that. So 2/8 is 0.25. So then 1/8 would be half of 0.25. Or you could do 0.5 for that 1/2. So half of 0.25, 0.25 is like a quarter, 25 cents. So half of that would be like 12.5 cents, 0.125. So if we know that 1/8 is 0.125, 5/8 then, we would need that 5 times. So we would take 5 times 0.125, and when you multiply that out, you get 0.625. And whenever we have questions like this with the lines, remember that means we need to write in a complete sentence answer. So Keisha could use 1/4 equals 0.25 to determine the decimal equivalent of 5/8. So we would start with Keisha could use 1/4 equals 0.25. The next, to determine the decimal equivalent of 5/8. So that's the beginning of your complete sentence answer. And because if 2/8 equals 0.25, then 1/8 equals half of that. Which is 0.25, so, or 0.25. 1/8 times 5 equals 5/8, so 0.125 times 5 equals the decimal equivalent, so that's 0.625. So you can work in lots of the words from the question, and the work that you show is part of your answer as well, and then you just add in the extra tidbits. Next, which expression has a negative value? Well, we've looked at this before, and we can see we need to look at the rules for multiplication and division and the rules for addition and subtraction because they are different. Remember that for multiplication and division, there's the triangle trick or the tic-tac-toe trick that you can use to determine the sign of your answer. And we've got two negatives, so our answer is positive. We've got two negatives, so our answer is positive. We've got a negative and a positive, so our answer is negative. And then for adding, this would be a no. So then under our no flap, we subtract them, and then we'd see who wins. And the positives have 24, the negatives have 14, so the positives would win. So C would be the one that has a negative value. So you can find that answer without even actually computing it. Number 3, the temperature of a liquid in an experiment starts at 0 degrees Celsius. The experiment calls for the temperature of the liquid to change at a rate of negative 0.8 degrees Celsius per minute. And we learned about rates. Negative 0.8 degrees Celsius per minute. So that's a unit rate per 1 minute. How long will it take for the liquid to reach negative 10.8 degrees Celsius? Also estimate to show that your answer is reasonable. So we've got more than one task there. Well, if we look at approximately 0.8 in the negative is pretty close to 0.1, and negative 10.8 degrees Celsius is pretty close to negative 11. So it should take approximately 11 minutes. If we lose a degree every minute, we need to lose 11 degrees. So it should be approximately 11 minutes. So therefore, approximately 11 minutes. So let's see what the real answer is and whether that actually makes sense. So we can start with our complete sentence answer, and we can say it will take, and we can put our answer in however long, for the liquid to reach negative 10.8 degrees Celsius when it has change at a rate of negative 0.8 degrees Celsius per minute, or changing at a rate of negative 0.8 degrees Celsius per minute. So here we can set it up kind of the same way. Here we know that we've got degrees and then our per minutes. So we don't know our minutes. We need to find that part out, but we know that we are losing negative 0.8 degrees Celsius in 1 minute. We need to lose 10.8 degrees Celsius, and this is in how many minutes? So we've looked at before our sneak preview of proportions, where we remember that the cross products are equal. So negative 10.8 times 1 is negative 10.8. So when we multiply these two, and then that equals negative 0.8 times something. Remember, we can use a variable for that if we want to. And so when we're trying to find out times something, just like if you have 15 equals 3 times something, how do you find that answer? Well, we know that 15 divided by 3 gives us that something. So we're going to follow that same rationale. So remember, you can always make an easier problem. If you're not sure what to do, pick a problem that you do know how to do and apply to that same situation. So we're going to take the 10.8 and divide it by 0.8. Since both of our numbers are negative, just like we reviewed up here, two negatives, our answer is going to be positive. So as long as we know that. Plus we are talking about time, so of course it's going to be positive when we're measuring something. So we just need to divide, and I think I'll do that up here then. So I've got some room. So we have negative 0.8, negative 10.8, and we're going to move this decimal point over so it's 8, and then we'll move this one over to 108. So now we've got the same as 108 divided by 8. So when we do the division there, that goes in there once. 1 times 8 is 8. Subtract, and we get 28. Goes in there 3 times, which is 24. And bring down our 0. Put up our decimal point, don't forget that. 8 goes into 45 times, and that is 40. So we've got 13.5 minutes. And so that goes right here. And don't forget your label. So it will take 13.5 minutes for the liquid to reach negative 10.8 degrees Celsius when changing at a rate of negative 0.8 degrees Celsius per minute. So you can find the words to your answer right in your problem. So we should be able to tell what the problem was from your answer. So next page, and we're going to be using some of the same techniques we just talked about on the previous page. What is 5/7 written as a decimal? So again, top in the box. So top in the box, you're going to put 5 on the inside, 7 on the outside. I always just add 3 zeros so that I have enough. And when you divide, you're going to see that you get a repeating decimal, that after the 5, you're going to get 7 again. So that's why the bar is shown there so that you can write that out. But the whole idea of fractions is that they can be written as decimals. So right away, this one doesn't make any sense. 5/7 is less than 1, so that doesn't make any sense either. So right away, if you can eliminate out 2, that gives you 2 answers, and as long as you are dividing, 49, and we get 10, and does 7 go into 10 7 times? Is 7 repeating? No. So without even finishing the whole problem, you can eliminate out 3 of the answers so you know what is left. Number 5, true or false for each question. So here, again, you can actually figure the answer, or you can look at the things that you know. If we have a negative plus a negative, does that give us a negative? Yes. Let's check it out. -2 and -3, that's -5. -1/2 and -1/2 is -1. So -5 and -1 is -6. So that is true. The second one, if we have, we have to do our keep, change here because we are subtracting. So if we have 1 1/3 plus 7, is that going to give us a negative number? Certainly not. So that's false. Next one, let's see, we've got -1/4, and if we distribute here, this negative goes to both of these. So we've got -1/4 here and -1/4 here. +2 here, +2 here, -3/4 here, and then with distributing that negative, we've got -3/4 there. So true, that does work. And on this side, keep, change, so add the opposite. So we've got a -4 on this side, a -4 on this side, +12 on this side, and +12 on this side. So true, that one works as well. So next, which of these will give us a positive number? Well, any of them that we subtract, we need to do keep, change, keep, change. And we've got a negative and a positive for A. So there, and this is a no. So we subtract them and see who wins. Well, who's going to win? The positive is. So that one will give us positive. The second one, also a no. Subtract them and see who wins. Well, here the negative is bigger. So nope, that's not going to work. 4 plus 2. That one's easy. That's been 6 your whole life. The next one, a negative plus a negative, that gives us a negative. So that's not going to work. And E, -7/8 plus +6/7. Well, which one is bigger? How can you tell? You can always make a common denominator. And so 7 and 8, we could make 56. So 8 times 7 is 56. 7 times -7 is -49. 7 times 8 is 56. 7 times 6 is, or excuse me, 8 times 6 is 48. So let's see. We've got -49 over 56 or positive 48 over 56. So who's going to win? The negatives are. So just A and C will work for that one. All right, next, number 7, as water evaporates from a potted plant, its weight changes at a rate of -1 5/8 ounces per day. So again, there's our rate. Per means the fraction bar. So -1 5/8 ounces per day. So per 1 day. Estimate the change in the potted plant's weight. Explain your thinking. So explaining your thinking needs to be in a complete sentence. So if we estimate 1 5/8, 1 4/8 is 1 1/2. So that might be like losing approximately 1 1/2. So that's a good estimate, I think. So approximately 1 1/2 ounces per day. And 1 week, that would be 7 days. So losing 1 1/2 ounces, 7 days. So 7 times 1 1/2. 7 times the 1 would be 7. 7 times the half would be 3.5. So that would be 10.5 ounces. So that's just our estimate. So approximately 10.5 ounces. So we could say for our estimate here, as water evaporates from a potted plant at a rate of -1 5/8 ounces per day, an estimated maybe change would be good, an estimated change in the potted plant's weight after a week would be approximately, and here we go, 10.5 ounces. Explain your thinking. I know this because -1 5/8 is close to -1 1/2. Over 7 days, that equates to -10.5 ounces. So again, there are 2 sentences here. One I showed you just by highlighting. As water evaporates from a potted plant at a rate of -1 5/8 ounces per day, an estimated change in the potted plant's weight after 1 week is, or would be approximately, 10.5 ounces. And don't forget your negative 10.5 ounces. I know this because -1 5/8 is close to -1 1/2. Over 7 days, that equates to -10.5 ounces. So we want that in there. And part B, write and solve an equation using exact values to show the change in the plant's weight after 1 week. Well, I kind of already did that. If we want, though, the exact values, so 7 days times what it loses per day, and what does that equal? So we'd need to find the actual answer, and 7 times -1 5/8 is -11 3/8, and that would be calculated by, so we look at 7 times -1 is -7. 7 times -5/8, 7 times -5/8, well, that's going to be -35/8. And -35/8, we're going to use that same top in the box. So 35/8, and that goes in there 4. So 4 3/8. So if we change this to -4 3/8, -7 and -4 is -11, and we've got that 3/8 left. And of course, remember a label. So that would be ounces. And we estimated -10.5 ounces, so that's pretty close. We're about an ounce off. So why is our estimated total reasonable? So we could say my answer is reasonable because -10.5 ounces is very close to -11 3 ounce. There we go. All right, next one. In which situation do the quantities combine to make 0? So remember, opposites make 0, so -3 plus 3, or 1/2 plus -1/2. So when you have opposites, those will have a sum of 0. So let's see, Juan spent 20 bucks. The next day he earned $10 per hour for 2.5 hours. Well, $10 for 2 hours would be 20. So spending 20 and then gaining, but nope, that's not going to be 0 because he earned more. Erica deposited, so that's adding, $75 into her savings. She withdrew 75, that's negative the following week. Yep, positive 75, negative 75. The predicted temperature for a winter day is 7, and the predicted low is 14. Well, that doesn't equate to be 0, because if we are at 7 and the low is -7, that's actually going to be 14. We go from 7 down to 0, and from 0 down to -7. A deep sea diver descends 15 meters, so they're going down 15 meters, pauses, and then descends another 15. So down another 15, no. So now that's going to be -30, so down 30 meters. So that doesn't work, so just B works there. And let's see, true or false for each statement. 2.27 with the 27 repeating is a terminating decimal. No, because right here, that means that it's repeating when it has the repeating bar, so no. 3.14 is a terminating decimal. Terminating means stop, so yep, that absolutely is. The decimal equivalent of 13/6 is a repeating decimal. Well, top in the box. Remember, that's what we have to look at. So let's see, 13 in the box, 6 out here, and let's see, 2. That gives us 12. Bring down our 0. Then we get 10. That goes in there once. Then we get 4. Bring this down. 6 goes into 4 6 times, 36. 4, bring down a 0. Uh-oh, look at this. 6. Get 4. Add a 0. See what's happening here? 40. So we get 2.16, and we would have a bar over the 6. So that is true. The decimal equivalent of 9/4 is a repeating decimal. Let's check it out. Top in the box. 4 goes in there once, twice. And let's see here. Bring this down. We subtract 8 and from 9 and get 1. 4 goes into 10 twice. Subtract 8 again and get 2. Bring down a 0. 4 goes into 25 times, which is 20. So we have a 0 remainder, and that means a terminating decimal. So false. That's not true. Next section, in which situation could -16/4 represent? Well, let's see, a temperature increases 16 degrees over 4 minutes. So the temperature increased by 4 degrees per minute. Increased, -16/4 equals -4. So nope, that's not going to work. Each of 4 golfers has the same score after 18 holes. The total of their scores is -16. So each golfer's score is -4. Yep, you would take -16, and how much is that per golfer? They all have the same, so that would be -16 divided by 4. They all have the same score. A football team loses 16 yards in one play. They gain 4 yards in the next play. In the 2 plays combined, they lost 4 yards. No, that is just adding and subtracting. And D, over 4 weeks, Monique withdraws $16 from her bank account per week. So $16 for each week. Well, then for 4 weeks, that would be $64. Negative 16 over 4 does not equal positive 64. So just B works for that one. 13. Describe a situation that could be represented by the expression. Well, let's see. We have 6 plus a negative 325, and that could be that Jane had $6 and spent $3.25 on lunch. So she had $6, that's positive, and spent, that's negative $3.25. Find the sum and see what it means. Well, we've got a no, so we subtract and see who wins. So $6 minus $3.25, that's going to give us $2.75. So 1, find the sum, we got it. 2, explain what it means. Jane has $2.75 left. There you go. 14, let's page here. Add or subtract, represent each equation on a number line. So we still have to use our keep, change, change. Remember, we always start at 0 on a number line. Okay, I think my microphone shut off on me here. I'll go back, I'm not sure how much you got. Keep, change, change. You always start at 0 on a number line, always start at 0. So you start the first number after 0. We move to negative 28. Then we adjust for the second number. So adding a positive moves us to the right 16. So plus 16, and we land at negative 12. For B, we start at 0. Then we go to the first number. So that goes to 45. Then it has plus a negative 12. So we subtract 12, and we land at 33. For C, it's the same exact thing, just that the two sides are flip-flopped. So again, we start at 0. We're going to move to the first number, which is 15. Then we're going to adjust for the second number, negative 37. So that takes us to 0, and then some. So this is minus 37. And so then we end up at negative 22. So that's where we land. Okay, next, Cody claims that when 1/6 is multiplied times a negative number, the result will always be less than 1/6. Well, we know that if we take 1/6, which is positive, and we multiply it by a negative number, it's going to be a negative. So it will always be less than 1/6. Do you agree with Cody? So I agree with Cody. Please don't start with yes or no. I agree with Cody. A positive number times a negative number is always negative. And all negative numbers are less than 1/6. So examples to support, well, let's see, 1/6 times negative 1 equals negative 1/6, and that's less than it. 1/6 times 1 would be positive 1/6, so there's a non-example, but that is, well, that equals, I guess. I shouldn't say it doesn't equal it, but that does not follow we want positive times a negative. So this supports that. Negative 1/6 times positive 6, that equals negative 1, and negative 1 is less than negative 6. So, do you agree with Cody, first part, and explain? I agree with Cody, then I explained, and then I gave some examples to support my answer. So please make sure you do all of those pieces. Okay, and somehow my page is stuck and I didn't get the page is number 9 in there, so let's go back to that. The temperature of a solution in a science experiment is negative 6.2 degrees Celsius. Jessie wants to raise the temperature so that it is positive. So Jessie wants to raise that. So if we are at negative 6.2 degrees, we have to go up to 0, which would be, we have to add 6.2, and then at least a little bit more. So an example of a number of degrees that Jessie could raise that would be 6.3 degrees. Negative 6.2 plus 6.3 would equal 0.1. So there's an equation that would fit that. It just says of a number of degrees, so you could raise it by 100 degrees if you want to. Just make sure then that this matches raising it by 100 degrees. Draw a number line and use arrows. Well, looky, looky. I've already done that. So negative 6, and there's 10 dots in there, so negative 6.2. We start at 0, and we go to negative 6.2. Then we add 6.3. I went just a little too far there. We want to just go up to 0.1 degrees. So plus 6.3, and we land at 0.1 degrees Celsius. For the bottom part here, we want to fill in these blanks to make each equation true. So for letter A, you should try multiplying those. You multiply like normal, and then you're going to put 2 decimal places into your answer. So you should pause this, work that out, and see what you get, and then you can start the recording again to compare and see your answer. Okay, you should have gotten 2.6. Next, something times 9/5 equals negative 27. So remember, if you're confused, do a simpler problem. Something times 2 equals 10. Well, what times 2 equals 10? That would be 5. 10 divided by 2 equals 10. So we need to do negative 27 divided by 9/5 to get our number. Negative 27 divided by 9/5. So pause the recording, try that out, and then unpause when you're ready to check. Remember, negative 27 over 1, change this to multiplication and use the multiplicative inverse or reciprocal. 27 divided by 9 is 3, so that's a negative 3. 9 divided by 3 is 3, and we can still divide. We can do 3 divided by 3 is 1, so we've got negative 1 though. 3 divided by 3 is 1. So when we, let's see, let's go back a second. I don't think I did that all the way right. We want to negative 27 over 1 times 5/9, and let's just go right away with dividing them each by 9. That's where I did it wrong. I divided 1 by 9, but 1 by 3. Negative 27 divided by 9 is negative 3. 9 divided by 9 is 1. So negative 3 times 5 is negative 15. 1 times 1 is 1. And then we can clean that up to just make it be negative 15. Sorry about that. Letter C. Here we've got a little chance for you to recall order of operations. So we've got -6 divided by -3 times -5. So parentheses, nope, these are just packaging a negative. Exponents, nope, there aren't any. Multiplication or division, yep, there's both. How do we know what to do? Left to right. So go ahead and solve that problem and then unpause when you're ready to check it. So first we're going to do this problem, -6 divided by -3. And then times -5. So this part here is going to give us 2. Bring the rest down. And now we've got 2 times -5, and that's giving us -10. Look at that pizza slice there. So -10. For D, something divided by -2/3 equals 3/10. So again, make an easier problem. Something divided by 2 equals 10. What divided by 2 equals 10? Well, that would be 20. So 10 times 2 equals 20. So we need to multiply these two fractions. So pause, multiply those out, and see what you get. For D then, we've got -2/3 times 3/10. The 3 and the 3 can both be divided by 3. -2 divided by 2. And 10 divided by 2. So we get 5 and we get -1. And then -1 times 1 is -1. 5 times 1 is 5. So we get -1/5. And the last one is kind of similar to letter C. Something equals -4.5 divided by 1.8 times 3.2. So again, order of operations, we've got just multiplication and division, so you go left to right. This would be the same as if you had equals and the answer key or answer box, over here. So you don't start at the 3.2, you start at the -4.5. So you're going to divide the first two, and then whatever answer you get, you're going to multiply by the last, and you will get -8. So remember, when you can look on your rational number cheat sheet, when multiplying decimals, you multiply like normal and then give it the number of decimal places you need. When you're dividing decimals, whatever number's on the outside, you need to make that be not a decimal. So if we move this over one spot, we move this over one spot. So it's kind of like 18 into -45. Get this answer, multiply it by 3.2, and you should get -8. So I think that clues you in on what you should have to do, and go have some banana pudding. Let's see. So study tips, use the study guide. This whole packet is a study guide. If there's something you don't understand on it, that means you don't understand it for the test. Study ahead of time. That doesn't mean the morning before, the class period before, or even just the night before. Attend study sessions. That's what this whole screencast was a study session. Hopefully you took breaks, because it was kind of a long one by the time we got through all of that. So don't only study the night before. You should study the night before, but make sure that's not the only time. You should study in little bits often. Only study what's easy. Well, that's what's comfortable, but studying what's hard is going to make you get a better score. Cramming your work in, not a good idea. Relying on other people somewhat, that's okay. You could study with a group, but to solely rely on other people, no. You need to make sure you rely on yourself. So math rocks and so do you. See you next time.